Hi, here we are again on day 2 with logs.
And we are going to solve some log equations.
Right. If you remember from the last podcast, what do we do when we want to solve a log equation? We do the ear.
All right. This is actually, we're not solving yet.
We're not
if
solving
we
yet.
better read the directions. So it says change to exponential form. And I knew right away we weren't solving because there's no variable here. So to change to exponential form, we just want it written in exponent form. So we have 10 to the second, our ear,
Yep.
equals 100.
So the 10 is popped up by 2, and 100 equals 100. Check. We're happy. Now let's do this one. We start always with the base. So the base is 2 raised to the minus 2 is equal to 1/4. And we all know that is a true statement, right? 2 to the minus 2 is
1 over
1/4.
2
1 over 2 squared.
And that's just 1/4. Check.
Let's start with the base. 3 to the 1/5.
To the 1.5.
1.5. Same thing. Equals square root of 27.
This all sounds really familiar to me. Does it sound familiar to you, Miss Barb?
Yes.
Okay. Oh yeah. Because this is our second time doing this podcast.
Okay, so I don't like 1.5.
That's super ugly. Let's change it. Let's change 1.5 to our
3 over 2.
because fractions are our friends.
Yeah. 1/2.
But still not looking very convincible here.
No, we want to get these in the same base, right?
All right, well, if this has a base of 3, we want to ask ourselves, can we rewrite 27 to also have a base of 3?
Yes.
So 27, base of 3, what would it be?
3 cubed.
3 to the third, because
Yep.
3 times 3 times 3. So I could say that this is the same thing as 3 cubed. Now, if I leave everything else the same, I still have here a 1/2. And over here I have
3 to the 3/2. And if we have an exponent raised to an exponent,
then we multiply.
multiply.
So we have 3 to the 3/2.
Happy.
And there we go, we checked it. And if it's asking us to change it to exponent form, we'd probably be looking for, I think we would take either one of these two answers here.
Yeah.
Okay. Next page. Now we're solving.
Now we're solving.
we have
So
some
we
variables.
set it up the exact same way. We have the variable here of x in the first one. We start with the base.
So log base 7 of x equals 2. So we start with base of 7. We raise it
Pops
to
it
the
to-
second power.
Come around, and that's equal to x.
So therefore, 49 equals x.
Yep.
We're done.
Let's look at this one. Same thing. Start with the base of 4. This time our variable is a. It doesn't matter what our variable is.
So we have 4 to the third equals
A.
And 4 to the third, I know that one by heart. It is
64.
is A. And we're done.
Okay.
These aren't so bad.
No. Now let's talk a little bit about what do you do if there's not a base, right?
Well, in mathematics, this is another one of the assumptions. If log is written without the base, it's assumed that it's actually a base of 10.
Right? So it's almost like, you know how we've learned this week that the square root is written without the 2? And we've also learned that if you have 1x, or you know that you just write x, you don't write 1x. So this is another one of those, right? So log written without a base, you assume that it's base 10.
Okay, so if I just put my little 10 in there just to keep things straight for the first one,
Yeah?
I would say 10 to the second
is
equals
equal
to
x.
x. So this would just be written as log of x equals 2.
Right.
We don't have to say log base 10, but we do have to say, if we're looking back here at the previous problem, we do have to say log base 4 of a equals 3.
Right. But if you just say log, it's assumed that it's the base 10.
All right. So we know now x is just
100. Here we have, let's set it up again, 10 to the 1/2.
So I have 10 to the
1/2
1/2 equals
x.
x.
10 to the 1/2, what's that?
Square root of 10,
Yeah.
and that's x. And that can't simplify any further.
Nope.
So now again, if I had this little invisible 10 here, I have 10 to the,
Minus 1.378
and that is all equal to
x.
x. Now if we wanted to evaluate that a little bit further, maybe I could do it up here, but depends on if we have a calculator or non-calc. Negative 1.37, was that right?
1378, wasn't it?
1378. 0.042. So x is 0.42.
Done. That's it.
All right.
Thanks.